Hi, I'm Oluwakemi. I'm excited to have you here again. This is JAMB Physics 2017 and the question goes thus. If an object is located 25 centimeters from a convergent mirror with a radius of curvature of 10 centimeters, calculate the image distance from the mirror. So first we're going to take a look at the mirror equation for a concave mirror, which is 1 over the focal length represented by the letter F equals 1 over the image distance represented by the letter V plus 1 over the object distance represented by the letter U. Okay, good. So first we need to remember that the focal length is half of the radius of curvature, okay, and the radius of curvature is given in the question as 10. So if we divide that by 2, we have the focal length as 5. So that is what we're going to input. That's the value for focal length. Okay, so we have 1 over 5. All right. And for the value of V, remember that is the image distance. That is what we're asked to calculate. Okay, so that is what we're looking for. Okay, then for the object distance as shown in the question is 25. All right, so now we need to move 1 over 2 to the other side. That is, we're going to subtract it from the both sides of the equation. Okay, so we can just quickly rewrite it like this. So we have 1 over 5 minus 125. All right, good. So 1 over 4, if we look for the LCM of 5 and 25, which is 25. Okay, 5 and 25 is 5. 5 times 1, that's the numerator. We have 5. All right, 25 and 25, 1 times the numerator is 1. So finally we have 4 over 25. All right, so now we're going to invert, okay, in order to find V. So we're going to invert the fractions on both sides. So we have V finally equal to 25 over 4. Then if we punch these on our calculator, we're going to have a final answer that is a decimal number of 6.25 centimeter. So this is our final answer, and this goes with the answer option A. So thank you for watching. See you in the next video. Bye bye.